Okay, some of my friends thought it'd be kind of funny if I did one of my weekly informational videos in the style of a viral TikTok video. So here I am in the bathroom. I'm holding a random household object. I'm staring at my phone and not at you until eventually I put my leg up on the counter. I zoom in, finally make eye contact and say, "Welcome to week 3. Hey everybody, welcome to week 3 of CS 201 here in the summer session. Apologies, I actually reused that cold open from the winter session just because my son's with me this week. I knew there was no way I'd get to record anything extra. I'm gonna be lucky if he doesn't come barging in during this one. Let's start with week 2. Week 2, apologies. The weighting on the unit tests for your grade scope were kind of off, so hopefully I didn't freak you out. I know I've messaged a few of you. But it says that you got 60 out of 70. You got all 70 points. The last one should be worth 20. The weighting was just off, but from past experience, if I start messing with the auto grader while people are submitting, I sometimes get really weird errors. But don't worry, I checked the assignments for this week. They are correct. Week 3 is going to be a bit more kind of programming oriented. We're going to talk about more control flow structures, things like that. The first thing is going to be conditionals. So conditionals are, just associate them with the word if, right? If this thing is true, then I want you to do this one thing. Maybe that's not true. So there's this other word, elif. Elif just stands for else if. If the weather is sunny, then we should go surfing. Elif, the weather is rainy, we should stay indoors. Elif, and then like you have lots of different conditions, right? Because not all branches in the world only have 2 options. Sometimes you might have 3 options, 4 options, whatever. And so you've got sort of if, here's kind of what I want you to do. If the first thing is true, elif, a bunch of different options. And then the last one is else, that's your default. If nothing else matches, you're gonna do that one. And the thing about branching, and I say branching, I don't think Chris used the word branching when he made the videos, but this whole idea of these conditional if statements, right? Those conditional statements, like they're mutually exclusive, right? If you want to have things that aren't mutually exclusive, you would just have different branches, right? You'd have if, elif, else, and then a separate if, elif, else later on. But like, yeah, the idea is that you're just going to find the first one that matches, and then you're going to execute that, and you're going to leave the branch entirely. So once you take a path, at least in this way, this sort of structure, you can't sort of go back and choose a different path or take multiple paths at the same time. There might be ways of doing that, but not for this. And then that's going to get us into loops. Loops, of course, super valuable because, at the end of the day, I feel like this entire class is leading us to being able to parse big data using, some simple scripts, right? Like I just need to, grab a whole bunch of, mortgage data, calculate the some percentage that matters to my higher ups somehow, and then pull up a list of all of our customers who meet that, criteria, whether that's good criteria, bad criteria, whatever, and then produce an Excel spreadsheet with all those customers' information on it, right? Like that's the sort of thing. I'm choosing a business example because in Fresno, I teach in the business division, so I kind of teach in business and math, science, engineering. Don't worry about it. Point being, whatever works for your particular thing, right? If it's medicine, maybe it's, hey, we need to go through all of our patients, find patients who have, these exact symptoms or these exact metrics, and then we're going to use that to get a list of at-risk patients. Whatever it happens to be, using stuff to parse big data. And so loops end up being really important because if you've got thousands of customers or worse, millions of customers, yeah, you got to use a loop, right? I want to do this exact same process 1,000,000 times for every single customer that I see. That's going to be that looping process. By the way, when you're doing the loop section, there is a little exploration about the rabbits. Kind of pay close attention to that. It's not exactly the same as your assignment, but it's going to be kind of the most similar. So anyway, there's also exception handling. Kind of a weird time to bring up exception handling, but I guess that kind of makes sense for kind of where we're going and the different way that this class works. But exception handling is basically just whenever you're trying to program something. Now you've probably already gotten a lot of compile time errors, right? Compile time errors are actually good, right? Compile time errors are when, PyCharm or, Xcode or VS Code, right? Whatever you're using, it gives you a compile time error to say, hey, I think you've made a mistake. You've treated something wrong. That's great. That's like a friend telling you that you've got some spinach stuck in your teeth before you leave for lunch, right? Your compiler is your friend. It's helping you out, right? Runtime errors are errors that the compiler doesn't see. They're errors that happen while you're actually using the program, or maybe while somebody else is using the program, which is to say that if you get those errors, then all of a sudden people are writing really nasty things about you on like the Google Play Store, comments. This is where you kind of look bad in public. So you don't want those. The worst are the ones where it's one thing if your app crashes. It's another thing if your app gives bad information where there's no error at all. There was just you just put in the formula wrong, or you did something logically wrong, but it still works as a program. It works just fine. It's just giving you the wrong answers. Those can be really, really bad. But regardless, exception handling is kind of for those runtime errors, the things that will come up that you can't foresee. The examples that we're going to use, a lot of it is just about like the input. You're reading something in, maybe from a file. We haven't even gotten to files yet. At this point, it's just input, right? Somebody's typing in input into the keyboard. What if they type in something that doesn't work? What if you ask for a number and they say, I don't know, Beetlejuice. Okay, well, Beetlejuice is not a number, right? I can't perform math on that. And so that raises an error. You may have even, in testing, gotten those crashes sometimes because you accidentally hit, something else instead of 0 or whatever. They're runtime errors. You can't anticipate what a user is going to type into your program when you write the program. But what you can do is actually say, hey, I acknowledge that what I'm about to do, taking user input in this case, is inherently risky. There could be an error. And so what I'm going to do is to try to do this. And hopefully it works. If it does work, life is great. But you can always put in the except, and then you have this exception. And then you say, what do you want to do in the exception? Now, you could technically go back and say, hey, this was a problem. Go back and actually ask the question again, like enter a loop. You don't have to do that. That's not the structure that Chris put up. We're going to keep it a lot simpler. In this case, you just say, hey, there was an error, and you exit, which at the very least is elegant, right? In the same way that like a common runtime error is you can't access the server, right? So like I'm writing a mobile app, and at some point it's like, hey, there should be some information here on the screen, but I can't access the server to get that. So what I could do is figure out why I can't access the server, or if even then I could just put in the words no internet or cannot connect to server. That at least tells the user that, oh wait, this app isn't the problem. The problem is I don't have my Wi-Fi turned on, right? Or I'm not connected to the internet, right? It suddenly shifts the blame. It explains what's going on. So even then, if it's just a message and you exit, at least you've explained what's going on. And that might keep people from giving you 1 star and really nasty comments, again, in the Google Play Store. And then there's another exploration where you kind of combine these things together, which is what you're going to need for your assignment. Your assignment feels oddly prescient, although it doesn't actually use the correct math for a virus. But we're doing zombie epidemiology. Don't read into it. We didn't know that coronavirus was going to happen when we started the class. But regardless, the idea is that you've given a formula. Basically, the formula translates to about 10% of the non-zombie population of Portland, Oregon gets bitten every year. So over time, what's the ratio between zombies and regular human beings? And so you could calculate all of these values using this formula for every single year from 2001 to 2029, displaying sort of the population of humans versus zombies in the city of Portland. You're going to be outputting this in something sort of specific. And if it feels weird, why is that such a specific format? And why is the assignment so being sort of anal retentive about, it has to be a number, comma, no spaces, another number, comma, no spaces? It's because even though you're just outputting it to the screen, that's what we would call comma separated values. They could be called CSV files, but they're really a common way of transferring data from one program to another. If you've got one big server and you want to transfer a bunch of information over to another server, you might use a CSV file. Some of you probably have some experience with Excel. You know that Excel can open up CSV files natively in Excel, and then you can start using whatever you use Excel with. Comma separated values will be something we use later in the class. It's a great way of being able to read in stuff and output stuff. There's some other formats too. We'll talk about JSON data, which is very popular on the web. So there's, just one assignment this week. And then just like last week, there's a TCA, team challenge activity, if you want to engage in teams. In fact, I thought about it. I'm going to open up the people tab and I'm going to create some groups. I'll just name them after something. But then we can use those groups so that if you want to, you can just self-join into a group, like if you find some people you want to work with, and then you have another way of collaborating and communicating and sort of sharing documents and stuff. So anyway, I'm sure you found other ways of doing that. Students are very good at communicating with each other, but we have groups. I might as well create some for you. And they'll just be generic groups, and like I said, anybody can join those, so you can kind of decide who you want to partner with. The TCA is for zoomies. This is not a term I'm familiar with. He apparently grabbed it from the Urban Dictionary, but I don't have any pets. So apparently this is what your dog does while you're gone. And so the idea is that this is going to be a zoomie counter. There's about 8 different activities your dog could be doing, from running, panting, whatever, and then napping. And napping is the important one because your program is essentially going to take input. So you just keep taking input from the user of all the things that your dog is doing. And then you're keeping track of how many of each of those activities your dog has done, or this dog has done. I don't know, that's your dog you're calculating stuff for, but whatever. And so then you sort of, he panted 4 times, he ran 18 times. And then once you hit nap, once you see the word nap, obviously nap gets a count of 1, and then your program quits and displays the information or does whatever it's supposed to do. I think it's displays information. Like you just display it on the screen. Regardless, that is the team challenge activity. And basically it's a way of sort of, you're having to combine branches and loops in a certain way because you don't know when you're going to see the word nap, right? You're just going to keep going until you see the word nap. There could be just 3 activities. There could be 1,000,000 activities. I mean, theoretically that's impossible for a dog, but whatever. You know what I'm saying? Like, you don't know until you see the word nap. It's like, okay, that's what ends it. It's not going to happen a specific number of times. And that's what's kind of make it a little bit more challenging. Plus you have to sort of branch within each of those loops. So anyway, I'm sure some of you will be able to get it. It's worth 10 points of extra credit if you need it. But yeah, those are your 2 assignments for this week. The assignment on zombie epidemiology, which does not use the R0 standard that we use for viruses if you're talking about coronavirus and epidemiology. Your TCA on zoomies, and if you have any questions, send me a message, and I will get back to you as soon as I can. All right, so good luck, and I will see you online.